You know, when we think about security cameras, our minds usually jump to things like image quality, how far it can zoom, or how well it sees in the dark. But what about the recording itself? Video storage. It's not just some extra feature. It's the whole reason we have the cameras in the first place. It's your evidence, your record. It's your last line of defense. So let's really dig into what it takes to make sure it's actually there when you need it.
So it almost always starts with this one simple request. You hear it from clients constantly. And on the surface, 30 days of recording sounds super straightforward, doesn't it? But believe me, packed inside that one little sentence is a whole world of complexity that really separates a professional system from one that just gives you a false sense of security.
Right? Because that's what this is all about. It's not enough to just have a hard drive spinning away in a closet somewhere. It's about making sure that when something bad happens on day 29, the video from day 1 is still there. It's accessible, and it hasn't vanished because of some technical glitch you never even thought about.
So to get this right, we have to stop guessing and start doing some math. Getting that 30 days of video isn't magic, it's a calculation. It's a math problem with a few really key variables that tell you exactly how much storage you're going to need.
And here they are, the big four. First up is bitrate. That's just a fancy word for how much data each camera is creating every second. It's based on things like resolution and frame rate. Then, obviously, you multiply that by how many cameras you have and for how many days you need to keep the footage. But this last one, recording mode, that one can totally change the entire game.
So you've basically got two ways to go here. You can do continuous recording, which is exactly what it sounds like. It records everything, 24/7. That includes hours and hours of an empty hallway at 3 a.m. Or you can record only when there's motion, meaning the system only saves footage when something is actually happening in the scene.
And let me tell you, that choice is a huge deal. We're not talking about a small difference. You can literally burn through 60% of your hard drive space recording absolutely nothing. Just by switching to motion-based recording, you can make your storage so much more efficient.
Okay, so we've done the math and figured out our storage needs. We're all set, right? Nope, not even close. Now comes maybe the most critical part of all, how we protect that data from the one thing we know for sure is going to happen. This is just a fundamental truth of tech. They're mechanical, they have parts that spin thousands of times a minute, they wear out, they all eventually break.
And in a security system that's running 24/7, that when comes a lot faster than you'd think. So you have to have a plan. Relying on just one drive is a disaster waiting to happen. When it fails, you don't just lose a little data, you lose everything.
So, the way pros handle this is with something called RAID. It stands for Redundant Array of Independent Disks, which is just a really clever way of linking multiple hard drives together so that if one of them dies, your data, all that critical video footage, is still safe and sound.
Now, there are different levels of RAID. RAID 0, forget it. It offers zero protection. You never, ever use that for security. RAID 5 is okay. It lets you survive one drive failing, which is fine for smaller setups. But the real industry standard, the one that professionals swear by, is RAID 6. Why? Because it lets you survive 2 drive failures.
And this is the absolute key difference. See, RAID 5 protects you from that first failure, but the second that drive dies, your whole system is in a really vulnerable state while it's trying to rebuild the data onto a new drive. RAID 6 protects you even during that high-stress period.
You're probably thinking, what are the odds of 2 drives failing that close together? Well, it's way more common than you'd imagine, and it leads to something we call the RAID 5 nightmare scenario.
So picture this. Everything is running perfectly. Then bang, a drive fails. No big deal, you've got RAID 5. You pop in a new drive, and the system starts rebuilding. But that rebuild process puts a ton of stress on all the other drives. Drives that are probably the exact same age and from the same batch. And that's when it happens. A second drive fails under the strain. With RAID 5, that's it, game over. Every single bit of your video is gone. Poof, forever. That right there is why RAID 6 is the standard.
All right, so we're planning for failure with RAID 6. Awesome! But we can also lower the chances of failure in the first place by just choosing the right tools for the job. And trust me on this, not all hard drives are created equal. The standard drive in your desktop computer? It's built to run maybe 8 hours a day, and it's mostly optimized for reading data, like when you open a file. A surveillance drive is a whole different animal. It's engineered to run 24/7, all year long,
and it's built for one specific brutal task: continuously writing huge streams of video data without ever stopping.
And this chart really tells the whole story. The job of a surveillance recorder is almost all writing, all the time. 95% write, 5% read. You only read the data when you actually need to review an incident. Using a desktop drive for this is like trying to use a sports car to haul gravel. It's just the wrong tool.
And using the wrong tool has a very specific, very dangerous consequence. It's called frame skipping. A desktop drive might hit a tiny error and decide to pause everything to fix it. But while it's paused, it's not recording, and that split second could be the exact moment the one critical event you needed to see happens. Surveillance drives are designed to power through that, to prioritize getting the video written down no matter what.
So we've protected against drive failure. We've picked the right drives. But what about an even bigger problem? What if the network cable gets cut, or the whole recorder just dies? We need one more layer of protection, a final safety net.
And that safety net is called edge storage. It's actually a pretty brilliant and simple idea. You just put a small memory card, like a micro SD card, right inside the camera itself. It basically turns every camera into its own mini backup recorder.
So here's how it saves the day. On a normal day, the camera is just streaming its video to the server. But if that connection breaks, the camera is smart. It instantly knows the network is down and starts recording right to that little SD card. Then, as soon as the network comes back up, the server automatically reaches out to the camera, grabs all the footage it missed, and seamlessly weaves it back into the main timeline. It's a self-healing system.
This whole process even has a name: Automatic Network Replenishment, or ANR. But what really matters is the result: a complete, unbroken video timeline with zero gaps. The system literally fixes itself to make sure you never lose the evidence.
So let's wrap it up. Here's your playbook for doing video storage the right way. 1. Calculate your needs. It's math, not a guess. 2. Plan for failure. RAID 6 is the standard for a very, very good reason. 3. Use the right tool for the job, meaning 24/7 surveillance drives. And 4. Build in that safety net with edge storage to protect you from the big disasters.
It's pretty amazing, right? What starts with a simple request for 30 days of recording turns into this whole multi-layered strategy of math, redundancy, and resilience. It just goes to show you that real security isn't just about the camera you see on the wall, but all of this complex, invisible engineering working tirelessly behind the scenes to keep you safe. Makes you wonder, doesn't it?